Hello and welcome to the third video in the Arduplane Build 2025. Do check out the other videos in the series. They're arranged so that if you haven't done this before, you can go through and hopefully it will make a lot of sense. The vast majority of the stuff I'm going to go through is identical to all of the other Arduplane builds that I've done, because one of the things that Ardupilot and Mission Planner are really good at doing is keeping things the same even when features are updated. Now, last time we were setting up things like Express LRS, the GPS and the compass, doing all that basic configuration. Now that's done, we're ready to actually do some final tweaking bits and then think about how we're going to site the GPS and also install the Cube Pilot inside of this He-Wing T2. It's not as easy and straightforward as I hoped, but we'll get into that in this video. By the end of it, it'll be in a state where in the next video we can look at maybe adding some FPV equipment in. I'll probably drop some walk snail stuff in here, show you how to set that up, and then we'll get into a maiden flight video. And also we'll do some tuning with it as well, using probably the next version of Arduplane that's about to come out as I'm making this series. I'll probably hang on for the tuning in case something is different with that. Big thank you to 3DXR for supplying both the Cube and the Here 4 that we're using as part of the series. Don't forget, as part of the series, I've also shown how you can flash Ardupilot on something like a SpeedyBee F405 wing if you don't want to spend the kind of money that getting something like a Cube Pilot Orange Cube Plus is going to run you. Those things aren't cheap, but you can use Ardupilot on basic hobby grade flight controllers now without sacrificing too many features. So let's get into the video. I'll put timecodes down below and hopefully by the end it'll look like a plane that's pretty much ready to go. So there's a couple of things that I like to do at this point just before we go any further. Most of this stuff is going to be done in Mission Planner. If we jump over here into Mission Planner, you can see that the ADS-B stuff is working. I can see the planes coming in and out of my local airport, which is Manchester Airport. You can see the ones that are coming in, going out, taking off, and that is all due to the fact that there is this little antenna on here which is receiving that ADS-B information. This is quite a fun thing to do. Sometimes I have this just running on my bench just to see who the planes are that are in the air that I can see out my window. So because this GPS does not have any kind of safety button on it, some of the older ones, different ones do, you have to press the safety button before you can arm it. This one doesn't have that. We need to set that up. That's quite easy to do. Here in good old Mission Planner, go into the full parameter list. Over here on the right hand side, search for BRD underscore safety, and the safety default, which is what you want here, by default is going to be 1, which is what it is. Make sure it's 0 and write the params, and then that'll all be good. Next thing we can do then is we can configure failsafe. If we go into setup, go into mandatory hardware, in here is the failsafe settings. I would make sure that you always have this set. I have it set for things like return to launch and those kind of things. There are settings here that you can change, and I would do this at the very end of the build, but just keep in mind failsafe is something that you always want to do and set up before you go too far. Next thing I would talk about then is the mappings. Now there's an awful lot of outputs here on this particular carrier board. We have 8 main outputs and we have 6 auxiliary outputs. I would recommend, if you're setting something that's quite basic, just plug everything into the main out. There's differences on every flight controller. I'm not going to get too much into this. I may do a whole separate video about setting up D-Shot, but just for now, think of the fact that the main out is actually controlled by a separate processor on this carrier board, and the auxiliary out isn't. So auxiliary out can do things a little bit quicker. Not going to get into the detail, but what we're going to do is set up all these outputs so we know where to plug our servos when we plug this into the plane in a moment. So here in Mission Planner, we want to go into the servo output screen. And at the moment, there's only 4 outputs: an aileron, elevator, throttle, and a rudder on outputs 1, 2, 3, and 4. And here that would be these first 4 ones that are kind of towards the middle of the outputs. Now, on this particular plane, the way it works is that at the back, they have these cables. And at the moment, both of the ailerons go into one single output, and also both of the motors do too. I'd like to split the ailerons and split the motors. Why? Well, I personally like to have separate ailerons. It means that they can be trimmed and controlled and managed separately. But for the motors, I'd like them separate rather than on one connection, just because later on I might want to play with things like differential thrust to help with stuff in turns. So I'm going to split these connections here that are actually part of the model. So I need to set up here in the outputs a couple of things, and it's really, really easy to do. This used to be so complicated, but it's super simple. So what I would do is I would make the first two ailerons. So let's make this an aileron as well. If I just press A on the keyboard, it's going to do it. So there's my two ailerons. I'm going to get rid of the throttle for now. I'm going to make this elevator. So we have two ailerons, an elevator, and a rudder. And then I'm going to put the two motors on outputs 5 and 6, because the way this little connector is, I'm going to have to clip this off and make it into a separate connector. So I'm going to set it to be motor 1 and motor 2. So those are those two things. And we're going to have a little bit of a play around here. At the moment, some of the settings you can see, the middle channel position will probably tweak. So that's now 1500. The motors are set to go from 1100 to 1900. We might end up having a little bit of a play with this when we put it in, but now I know that my ailerons are going to go into 1 and 2, elevator into 3, rudder into 4, and motors into 5 and 6, and that's a lot of the tricky stuff set. The only other thing that I would just confirm is on. The fab thing about this is automatically going to trim all of the servos into the correct position as it flies along. This is something that I actually asked iNav to replicate because it works so well in the Arduplane software. Over here we want to search for servo auto trim. By default it's set to 0. I would turn that on. It's such a fantastic thing. Why on earth wouldn't you want that turned on? So I would turn that on, and then as we're flying around, all of those controls are going to be set. Now at this point I'm going to disconnect from the flight controller and I'm going to unplug it from the computer. And the next thing we need to do then is think about the power module. Now by default, everything at the moment on here is being powered via the USB cable, which is fine while we're on the desk, but a bit tricky when we're flying around. So what we need is some way to power the flight controller. Now on things like SpeedyBee and Matex and stuff, it has kind of a power distribution board that's part of it. However, this more modular system and the Pixhook style flight controllers along things like the Cube Pilot have something called a power module. Now this power module is going to plug into the battery, and then the other side is going to plug in the lead that would normally plug into the battery, and it kind of sits in the middle. And its job is to do a couple of different things. First of all is to measure the battery voltage, also measure the battery current that's being pulled, so those can be reported, but also supply the different voltages that's needed. Now along in all the bits that you get, you're going to want the cable that says power cable. We're going to plug that into the side, and then we're going to plug that into power 1. There is the option to have redundant power systems on here. Again, one of the fab things that things like the Cube Pilot and others can do. Just need to make sure we get this the right way round. It's quite a big connector. Right, so now I can power the cube from a battery, and then we can set this up, and then we're almost ready to install this into the model. So let's power it up for the first time from a battery. And then we'll plug it into the computer and we'll have a look at the power module settings, because that needs to be potentially configured too. Let me plug it in here. We'll connect again. Look at additional hardware. In here should be a battery monitor, and it's automatically populated itself. By default, this would all be empty, but it now says it's analog voltage and current, 7 cube HV power module, and it's set for cube orange. it has set all that stuff up perfectly. If we go onto the data screen, we should see the battery voltage, which is 16.1 volts, currently pulling 0 amps. So at the moment, I would probably come in here and potentially tweak it, but at the moment it's close enough that is all set up. So now we're at a point where we're actually in really good shape. This is now at a point where we can actually think about putting it inside the plane. So let's get that and start doing a little bit more thinking about where everything can go. So in terms of getting the cube inside this model, let's start not with this thing, let's start with the GPS. Now, the GPS is here on the back and mounted so that it's in the same plane as the flight controller, so it isn't on a tilt. I've had to create this little 3D printable piece. The foam that actually comes as part of the GPS lifts it nice and clear. I've got it pointing so that the little arrow is pointing towards the nose of the model, and the cable is coming into the body. I'll share this little adapter thing that I've made. I just glued it in with a bit of good old Yoo-hoo paw and stuck this on the top, and the GPS is done. So no particular drama. Next thing to think about then are all of the pieces here. Now, as I talked about just now, each of these by default had only one connection. So the ailerons were in a Y cable, so were the ESCs. Now, each of them have these kind of 4 bits. Interestingly, the way they've done it, hopefully you can see here, the flaps are actually separate, and I'll probably make a separate video showing you how to set up flaps if you want to do that. I'm just going to expose one of the channels on the radio out on 2 of the spare outputs, but you can see here that they've already done this. Top tip, whenever I'm playing with something like this, you can see here I've wrote FL flap left, FR flap right. On here I've written A for aileron. This is just gold Sharpie pen. It means that when I'm plugging it all together, there is less chance, M for motor, of me plugging it in the wrong spot. The only other thing I have done, you'll notice that there's something plugged into the 12-volt bit here. Try not so it's shining on the camera. That goes all the way here to the front. That is going to power the FPV stuff. Luckily, as you can see, it says on this power distribution board that's part of this, which actually works beautifully for this build, that it's a 5-volt 7-amp BEC, which is perfect for everything we're going to need. And it's also 12 volts, 3 amps. That is going to be perfect for a modern HD system. So I've put that in. Now, I thought that, okay, well, now we've kind of done all the hard bit. It's just going to be a case of dropping this thing in, right? Because the cube can kind of fit here. And remembering that this is the front of the carrier board, could fit in there absolutely beautifully. Wouldn't that be fantastic? There's loads of room. I can get to all the ports really easy. The battery can come all the way back. Superb. However, I remember now why I had to mount, and this is why it always pays to measure twice and cut once. If you remember, the Speedy Beat flight controller that was in here was actually in that orientation. And the reason is, if I just pop in the carbon fiber rods here that are there to support the wings, daft design in my humble opinion, it means that there isn't enough room now to put the flight controller on this top deck. So I've just had a thought about this, and I'm thinking, okay, well, what do we do? Do we get a mini carrier board, which might work for something like this? No, there is actually enough room under here. So I can get the flight controller in under here, plug all of the bits and pieces into the back of it, and still more or less get to everything. The nice thing about the power distribution board, it's only held in by 4 Phillips screws, crosshead screws. I could take this out to get to it if I want to. So what I'm going to do is I'm going to put it underneath and plug the servos in. Again, don't forget, we've just set those up in the output stage. So the first 2 are going to be ailerons. So we're going to plug those into outputs 1 and 2 like that. So that's my ailerons done. The motors are not there yet. We need the elevator. The elevator is here on the back, and surprise, surprise, it has E written on it. Looks like a number 3, but it's upside down. Make sure that you're putting the cables the right way around. I've done it wrong here. The ground is at the top. So then we have the rudder. and then we have the two motors. Right, so we're just matching the setup that we've just done. The motors, again, I've split them. So the way that I split them is I just clipped off the extra wire, crimped it and put it in its own connector. And I just used a single connector with a spot of hot glue to make kind of a little L connector that's going to go in there. And I can put the flaps in the other two bits. So what I'm going to do is just sort this out, get it underneath. There are sticky pads that come as part of the kit that's designed to mount the flight controller. I'm going to use both of these, and the trick is then I'm going to have to try and slide it into place without the sticky pad hitting the bottom of it. I want it reasonably far back, so I want the maximum amount of room for the battery. Let me do that, and I'll come back and show you what it looks like. The power lead is here, and that's going to plug into the output of that. I'm probably going to have to make a cable that's going to run up here into the battery area that will then connect into the battery. But let me do that very quickly and I'll come back and show you. So here it is all together, and went together pretty much as I just described. So let's take off the top pieces so you can actually see what I've done, and it's kind of exactly what I thought I'd have to do. So Pixhawk Cube carrier board, let me get something that I can point with. Let's get a little stick, is down here. That is connected via the foam pads that are in the kit. GPS is plugged in here. GPS cable goes out up into the GPS as we've already looked at, and everything else is pretty much as you'd expect. That is the Express LRS receiver going into my classic Y configuration of the antennas up here. Power module is kind of tucked away here at the back, and I've made a power cable that comes all the way forward that can plug into the battery, and that's all there is to it really. The really nice thing is that because this power distribution board thingy, doohickey BEC all in one unit, is held in place with only 4 screws, I could actually just lift this up, which actually let me get this sighted pretty nicely. Only one other thing that I've done, and I kind of forgot to mention it last time. Of course, the USB cable is at the side of the cube, and I now can't get to it. However, there has been a USB port on this thing for a very long time. And this cable here that's plugged into the one called USB actually has 2 pieces on it. The first is this buzzer, which, guess what? I've just double-sided foam tape onto the top of here. So now we get the happy little Pixhawk APM mission planner beeps that we know and love. And the other thing is it terminates in a little USB cable. So now I can still plug it in. So this is great because it means that you can hide away things like the Pixhawk Cube and still have access. And if I just plug, I've got my computer by the side of me running Mission Planner. If I just plug this in to that little USB cable, make sure it's the right way around. It'll initialize, connect to the computer, make the happy beeps, and there we are, everything is powered. So now I don't have to worry about the fact that it's actually hidden away. Everything's connected as we talked about before. Time to put the wings on and do the servo and ESC stuff. So let's do that next. So now the wings are on the model, I've had to kind of move on to my dining room table because this thing is just physically so big. We have the radio by the side, powered up, ready to rock and roll, not connected to a battery, and also the props are not installed as well. Why are the props not installed? Well, there's 2 parts to this. One is to check that all the control surfaces are moving in the correct direction, both under control for the radio and as a result of uncommanded movement. Second and final thing in this video, I'm going to calibrate the ESCs. And we're going to calibrate the ESCs because at the moment, with this basic video setup that I'm doing, I'm using PWM to run the ESCs rather than something like D-Shot, and I may make an additional supplementary video where we'll set it up and we'll change them over. But for most professionals that I bump into, they're still running it with PWM, and to be honest, it kind of works really well too. So the first thing we need to do is have the radio on, all set and ready to rock and roll, because what we want to do is connect it to the computer. Don't have a battery installed at the moment. We're not going to worry about that right now. That means that the servos won't move initially Other thing for safety is remove your props. We are going to be playing with the motors. We don't want anything uncommanded happening on the desk if we've actually done something wrong. It's easy to do. So for safety, the props are off. So let's just plug this into the computer and let's have a quick look at some of the things that we're going to just check that before we get too far with this. So it's plugged in, it's going to go through its boot routine, and we're going to get the happy little... Telemetry's connected, that's good. We'll get the trills. That means the Pixhawk is happy. We have the double flashes, which means it's searching for a GPS signal. Here on the computer, we can go into the connect, just like we have done all the way through. And this time we're going to just jump into setup once we have a connection. So here we have the connection. It says it's not ready to arm. If I try and arm it on the switch on the bench, it'll tell me that we have a bad fix on the GPS. That's absolutely fine. It's just going to have to sit here. I am indoors, so it is going to take a minute or two just to get a good GPS signal. You can get all kind of weirdness on here. So, you know, AHRS isn't right and all kinds of wackiness. We're not going to worry about that for now. We're going to come back to that in a minute. The thing I want to show you is in setup, go into mandatory hardware, go into the flight modes. I would recommend that you have a flight mode set as manual. For me, it's this switch here. And that's going to switch me into manual mode. We need to move the control surfaces in manual because that's going to show us the maximum deflection. We need to set it up in manual, and then we're going to fly in fly-by-wire A or B or cruise or whatever other mode that we want, but it's manual that we want for this initial check. Other modes will work, but I find that manual is by far the simplest and easiest way to do it. So we'll just leave it in manual for now. Now we've got that, the other thing we can do is if we go into servo output, we should see that as I move the sticks on the radio, we're actually getting deflection one way and the other. So there's the ailerons moving, there's the elevator moving, and again the elevator appears backwards because that's the way it has to be for Ardupilot. We also have the rudder moving as well. At the moment the motors are doing nothing because right now we haven't armed the model. So let me just see where we are. We'll just jump into data. So here it says pre-arm AHRS not using configured AHRS type. Don't worry about that. It just means the GPS lock isn't yet good enough. And we know that by we still have the yellow flashing lights. So if I try and arm it, it's going to warn me that we are not ready to arm, and that's absolutely fine. However, we can still do the tests. So what I'm going to do, now I can see that the sticks are moving and the outputs are also moving. What we'll do is we'll make sure that we're in the setup tab, and in servo output we want to be here ready so that we can reverse by clicking on each of these radio buttons and set the minimum, maximum and trim positions of the individual controls. So I'm going to plug in my battery. Now I have, just for safety, just triple checked with my ohm meter on the power connection that there are no dead shorts, and that's obviously really important. So let me just plug in the battery and we should see, there we go, the servos burst into life. And as I move the ailerons, I can see that both of them are moving in the wrong direction. That's not a problem. I can just reverse them by clicking on the reverse radio buttons here. And now they're moving in the right direction. Now in manual mode, we're going to see the maximum deflection. And I think that's great. If I wanted to reduce it, I could reduce or increase the maximum and minimum endpoints. At the moment, I'm really happy with that. That looks great. I could also then trim it as well so that the control surfaces are in line, and these are pretty spot on. So I'm kind of happy with aileron. Next one then to worry about is going to be the elevator. Let me just move it on the bench a little bit so you've got that in shot. Again, apologies for shooting this in my dining room. This thing is just physically so big. So let's do the elevator. That appears the right way, which is great. And finally the rudder, which is the right way too. That's fantastic. Now the last check that we need to do here is that we need to check that all the control surfaces are actually working to correct any uncommanded movement. So we're going to go back into fly-by-wire A. We'll get a confirmation beep, and now if I lift the tail up, we should see, and hopefully you can see it there, that the elevator is coming up to try and correct that uncommanded movement. Similarly, as I rock it, I should see that with the ailerons, they are working too. That means that all the setup that we've done so far is spot on, and we can be really happy that that is all working. Again, trimming the middle positions is something that's easy to do just by changing the middle positions here in Mission Planner. That means then the final thing to do is going to be to calibrate the ESCs. So let's do that next. So as I mentioned, the final thing we need to do here is to calibrate these motors. Props are off for safety. Please always remember, remove the props when you're doing things on the bench. If you ever see me do it, I'm doing it for speed and I usually give a warning. But for something like this, we're going to need them off because we are going to run the motors briefly. Now, at the moment, we haven't got a GPS lock because we're indoors. We still have the two flashing yellows, which means that we can't arm it. There are ways to disable arming and other bits and pieces and the safety checks that Arduplane does in order to be able to arm it, which we need to be able to do for this. I would strongly recommend that you never play with any of this stuff because Arduplane works incredibly hard to make sure that you never launch and fly something that isn't in a ready state. Now here on the computer, you can see that it still says that we are not using the AHRS type. That just means at the moment that we haven't got a strong enough GPS lock. If I took this outside and we sat it in the garden, it would lock up very quickly and it would be ready to rock and roll. I'm going to need this arming. Now we're going to calibrate these motors again because I'm just using PWM. I have changed something and I talked about this. I put a note earlier in the video. If we go into the setup tab, then we go into the outputs, you can see here that I've changed what was motor 1 and motor 2 to just throttle. Now there's loads of things we could have. We could have throttle left and throttle right, which ultimately I'm probably going to set this up as because it is a twin aircraft and we can use the yaw to help it turn in the air. That would be a great thing to be able to do. But just for the configuration in the setup, I've just set them both to be throttle. And that's what we need for a plane. The motors and things earlier on, I hope that wasn't too confusing. That was just there to kind of remind me which was which. So now I have that set. What we need to be able to do is to be able to get these values here, these 1100 values, to their maximum, then plug power in so that the ESCs see that high position, calibrate, and then immediately drop the throttle back down. This is very standard stuff, but let me just show you how I do it. So we're going to need to arm the model. But again, if I go back into the data tab, it's still not got a GPS lock. It's not going to let me arm. However, I can force it. I'm going to put it into manual mode just so that there isn't any shenanigans with the throttle or anything else. And what I'm going to do is here on the computer, I'm going to go into the actions tab and there is an option here to arm and disarm. I'm going to click on arm. And it says the arming has failed because we haven't got a GPS lock that's good enough. Do you wish to force the arm? Now I'm going to force the arm. It's going to confirm. This is only something I would recommend using for something like this situation. So we are armed. We have an unhealthy AHRS. I wouldn't fly like this. However, if we go back into setup, we should be able to see that as I raise the throttle on the radio, those outputs will now rise to their maximum value. 1892 is what they're going to. With them at that maximum value, I'm going to need to plug in power, then immediately drop the throttle. Ready? That should have calibrated the ESCs. I know if it works, if I raise the throttle now, they both start at exactly the same point. Perfect. If I unplug the battery, go back into data and go back into actions, let me just disarm so that we're safe. Back to double flashing yellow. That is pretty much all the setup done. I'll just put the props back on and probably make myself a nice cup of tea. So there we have it. The cube is now installed in the plane. We have the control surfaces moving in the right way. We've calibrated the ESCs. we're kind of ready for the next bit. So join me in the next video where we'll probably do a little bit of FPV setup, and then we'll go to the field and we'll try and fly it. Thank you for watching my video. Check out the playlist, and adding Painless 360 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.